Okay, here we have our second to last rule for differentiation that from lesson 3.3. This is called the product rule. Okay, you're finding the derivative. We're trying to find the derivative of a product of something that could be considered two separate functions, product of two functions. And here is the rule for it. Okay, so the derivative of a product of two functions is equal to the first function multiplied by the derivative of the second function, and you add that to the second function multiplied by the derivative of the first function. So it's not too difficult to memorize. In fact, informally, you could also write this. Okay, this is not formal at all. This is not proper notation, but just to help remember that the prime notation refers to the derivative. I'm going to write the fact that this is informal, so we cannot use this notation on the actual test. But you could use two. I guess on multiple choice question, it doesn't matter. You're not looking for formality. We're looking to solve for the actual derivative, evaluate the derivative. So the answer for this one could be u prime v plus uv prime. You're adding. Okay, or the order doesn't matter. You could write uv prime plus u prime v. Okay, so once again, take a look at this. You're taking the derivative of one of them, multiplying by the other function plus the other function multiplied by the derivative of the first one. Okay, or depending on how you look at it. Okay, so what does that mean? Okay, let's take a look at this. Example 4, you could consider f of x to be a product of two distinguishable functions, well, separate functions. You could say something that you could consider to be two separate things. So you could let u to be x squared plus 1. You could let v to be x to the third power plus 3. U is equal to x squared plus 1. V is equal to x to the third power plus 3. And in turn, you could organize these four expressions before proceeding with the product rule. If u equals x squared plus 1, by using what we know so far, okay, up to this point, we could find the derivative of u to be 2x. And using what we know, we could find the derivative of v. We could differentiate v to be 3x to the second power. So now, using the product rule, so f of x is equal to u prime v plus uv prime. Okay, so using that fact, u prime. So we have 2x times v, x to the third power plus 3 plus uv prime. So x squared plus 1 multiplied by 3x squared. Okay, let me double check. So u prime v plus u v prime. So we got that, and then it's a matter of simplifying this expression, this sum. We get the product first here of the two expressions, which becomes 2x to the fourth power plus 6x, and then you're going to add that to the answer for the second product, which would be 3x to the fourth power plus 3x squared. In turn, you're going to end up with, okay, running out of space here, it appears that the final answer would be 5x to the fourth power plus 3x squared plus 6x. Let me check the answer real quick. 5x to the fourth power plus 3x squared plus 6x. Yeah, that's what we have. Okay, so and I want you, okay, also something that's, to me, it's interesting, at least to me, this is interesting. You did not have to use the product rule to find the derivative of this, because what you could have done is you could have multiplied the two factors to simplify them first, okay, before proceeding to differentiate. By doing so, you would have gotten x to the fifth power plus 3x squared plus x to the third power plus 3. And to find the derivative of that, just use the combination of the power rule and the constant multiple rule and the derivative of a constant. So you get 5x to the fourth power plus 6x plus 3x squared plus 0, which you don't have to write. And you can see that we get the same exact expressions, just in different order, but you could rearrange that to make it the same. So it works either way for this question. You could use the product rule, or you can simplify first and then find the derivative.